Hello, this is Ms. DB. In this video we are going to continue to solve systems of equations with substitutions. And sometimes for these problems we're going to have to do another step, which is to solve for a variable. So here's an example. We're going to first practice solving for a variable. We have 2x plus 2y equals 8. The directions say to solve this for x. It would be just as easy to solve this for y, but the directions say to solve it for x, so that's what we'll do. So we want x by itself. So we find the x and we see what's happening. We see that there's a 2y term added to it. We need to undo that. So the opposite of adding 2y is to subtract 2y. So we subtract 2y from both sides. That leaves just 2x on the left side, so we're getting closer to solving for x. On the right side, we can't actually take 2y away from 8, so we just write negative 2y plus 8. You could also write 8 minus 2y, either one. Now we have 2x equals negative 2y plus 8, but we want just x. 2x means 2 times x, so we need to divide everything by 2. We need to divide this term by 2, we need to divide this term by 2, and we need to divide this term by 2. So 2x divided by 2 is just 1x. Negative 2y divided by 2 is negative 1y, and 8 divided by 2 is 4, plus 4. Now we have solved this equation for x. So our first part of the worksheet, 1, 2, and 3, you're going to solve for the variable. Number 1 is very similar to the example problem with a little bit different numbers. Number 2 is even easier. It says to solve for y. Right now we have y minus 2x equals 10. There's the y. We have minus 2x after it. We need to undo the minus 2x, so the opposite would be to add 2x. So we need to add 2x to both sides so that we can undo it and get y by itself. Now remember that when you add 2x to 10, you can't actually take 10 plus 2x and get some number. We just get two terms that we'll write next to each other. So we'll have y equals, you can either write 10 plus 2x or you can write 2x plus 10. Either one is correct. And that's all you have to do. Now it's solved for y. In number 3, we have to solve for x, so we need to divide every term by 3 because 3x means 3 times x, and the opposite of multiplying is dividing. All right. The next one's what we're going to do is we're going to decide which one would be easier to solve for a variable. So we're not actually solving these equations yet, this system of equations. We're just going to practice which one would be easier, picking the easiest one. So if you can ever find a variable that doesn't have a number multiplied, that will be a little bit easier. And if you have a choice, pick the one that has a positive variable as well. So in number 4, we have x minus y equals negative 3, and then 2x plus y equals 12. You can solve equation 1 for x, you could solve equation 1 for y, you could solve equation 2 for x, or equation 2 for y. But you want to pick one that's the easiest. In this problem, there's two that would be easy. It would be easy to solve the first equation for x, because all you'd have to do is add y to both sides. But it would also be easy to solve the second equation for y, because all you'd have to do is subtract 2x from both sides. So you decide whether you want to solve equation 1 or 2, and then whether you're solving for variable x or y. And the same thing in 5 and 6. You pick which equation you want to solve for x or for y and just fill that in. You don't even actually have to solve them. You just have to explain which one you would pick and which variable you're going to solve for. Now this should look familiar because it's the same sequence chain that we used on the Solve System of Equations with Substitutions Part 1 assignment. And in this lesson we are going to have to do step 1. Last time step 1 was done for us, but now we will have to solve one of the equations for either x or for y. And then all the other steps are the same. We will substitute the expression for that variable into the other equation, solve that equation for that variable, then we'll take that answer and plug it into one of our equations and solve for the other variable, write it as an ordered pair, and finally check our work. There's an example here that you can follow along with, especially if you get stuck. And then there's some problems to do. Make sure you show all of your work. In number 7 and in number 8, the steps are written down for you to follow. So we're going to start with number like 9 or something so that we can go through all of those steps that you're going to follow. So I'm going to copy this sequence chain so that I can see it while I'm doing my work. I'll just put it right here. All right, so let's decide, let's do number 10. Let's decide first of all, should I solve for x or y? In which equation should I solve for x or y? There's lots of good answers for this one because it's not very hard to solve the first equation for x or for y, and it's not very hard to solve the second equation for y. Either of them would be pretty easy. Let's just take the top equation and let's solve it for x. So to solve for x, I have to undo the plus y. So I would get x is equal to 5 minus y or negative y plus 5. Either one is correct. I'll write it as 5 minus y. So that's what x is, 5 minus y. Now we write the second equation, 3x plus y equals 17. And wherever I see an x, I'm going to put 5 minus y in parentheses. So I have 3, 5 minus y plus y equals 17. So now with the 3 times 5 minus y, we're going to have to use the distributive property. Take 3 times 5, that's 15, and then 3 times negative y, that's minus 3y, plus y is equal to 17. Plus y is the same as plus 1y, so I'm going to put that there so I don't mess up. So now I have 15 minus 3y plus 1y. These are like terms. They're both y's, so I combine the numbers in front. Negative 3y plus 1y is the same as negative 2y. So I just wrote the 15 down and then minus 2y equals 17. I'm trying to solve for y, so my next step would be to subtract the 15 from both sides. So you'll get negative 2y equals 17 minus 15, that's 2. And then my last step is to divide both sides by negative 2 to undo the negative 2 times y, and we get y is equal to negative 1. All right, so let's see what steps we did. We did step 1, which was to isolate one variable in one equation. That was what we did right here, x equals 5 minus y. Then we did step 2. We substituted that expression right here. We did step 2 into the other equation. Then we just finished step 3, which was to solve that equation for the variable y equals 1. Now we're ready for step 4. Substitute the value for that variable, y equals negative 1, into either one of your original equations. So you get to pick, back in our original equations, which one looks easier. I think the top one does because there's less numbers, smaller numbers. And I'm going to take the y equals negative 1 and I'm going to plug it in for y. That would be simpler to write as x minus 1 equals 5 instead of the parentheses. And now I have to solve this for x. So I'll add 1 to both sides and I get x equals 6. Now we're ready for step 5. Write this as an ordered pair, 6, negative 1, and then check by plugging it back into the original equations. So when I check this, I'm going to put them back into my original equations, both numbers. So x is 6, y is negative 1, and does that equal 5? 6 plus negative 1 is 5, so it works in the first equation. And then I'm going to check it in the second equation. So 3 times x, that's 3 times 6, plus negative 1, we want to see if that equals 17. So 3 plus 6 is 18, plus negative 1 does equal 17 because 18 plus -1 is 17. 17 equals 17, so it checks in both of them. So then we know that this is indeed our answer. And you will do the other problems on this worksheet the same way. Number 11, number 9. Number 8 and 7 have the steps written out for you, but you'll be doing those same things that we just went through. If you get stuck or you want to work together, please let me know, and have a wonderful day.